Okay, let us go to the first topic of today, guest study called Holistic Safety Consideration for Automotive System. Okay, here the objective is to develop a safety system for automotive battery system management. Um, Here, the international function safety, ISO 26262 has to be considered whenever you go for any development of electrical electronics within the road vehicles up to means the road vehicle will have different weight, and for all those road vehicles you need to have ISO 262, and the motivation behind this project or the case study is to have a battery system which is meant to be the central part of battery powered electric vehicle. Or also this battery management system is very much important even for a hybrid electric vehicle as well. Now it is becoming very much important, both electric vehicle and hybrid electric vehicle. And the market is also booming with with the requirement of the battery management system as well. And again, when you say you have the electric vehicle and the hybrid electric vehicle, even the power density of the vehicle is going to get varied, and the lifetime or the cycle time is also going to get varied depending upon the charging and discharging of the battery. And even the power rating also is going to be different for different vehicles. Like even say when you take some of the examples like Nissan Leaf, it is having a value of 36 kilowatt hour, whereas the other vehicle will have different ratings. Okay, so considering all these aspects, it's very much important to identify the malfunctions which is there in the battery management system, and we need to lower the malfunction. So how you can identify the malfunction only if you understand the function of the system. So here it is very much important to understand the function of the system or function of the architecture. And looking at the functions or looking at the architecture, then you can understand what can go wrong, and you can develop the HRA for this particular system, and you can take the corrective action accordingly, as stated by ISO 26262, the workflow, and also we can go with the safety goal, meeting the safety goal for this battery management system. So here there can be some of the things related to chemical safety, because as far as the battery management is concerned, safety goal is important. As I was mentioning, you may have a number of safety goals. So here, when I say the safety goal for a battery management system, you have mechanical safety, you have chemical safety, because and even you have some of the toxic gas which is coming out, uh, and even that the chemical safety is also very much important, and even electrical safety is also very much important, and so all this safety needs to be considered as a part of your safety goal, and it is very much important to analyze those safety goal, and you have to have a detailed roadmap how to achieve the safety goal. All this needs to be considered during the development stage itself, during the concept, basically not development stage. So that needs to be a part of the concept stage. Okay, so let us go to the architecture of a battery system. This diagram shows the system architecture of lithium-ion battery. This is basically for lithium-ion battery. You have different type of lithium. You have different type of battery. Lead acid battery, it was the original one, and because of its weight um, and uh, less power density issue, people are going with lithium-ion. And there are a lot of other new battery advancement has happening nowadays. Even you have polymer ion battery, you have lithium phosphorus battery, lithium sodium. You have different variants. Okay, and one what we have taken for our work is lithium ion battery. And there are a lot of research is also going on, and it is coming up with some of the new technologies. But now for our study, we have taken lithium ion battery. So the BMU called battery management unit. The major function of the BMU is related to the electrical and thermal management, and also They have something related to diagnosis functions also they will take care. They also take care of installation monitoring and also some of the communication with they are the central part of the communication with some of the vehicle parts also. Here the electrical management, when I say electrical management, it involves the uh, charging of the battery and also discharging of the battery and it also helps you to monitor and evaluate the component with respect to the temperature. And even you have installation monitoring in the battery system. It's been coordinated between the vehicle and to the PMU. Okay, and even you have a housing which protects the battery system, and inside the housing you have all other features which involves DMU, actually connection, high voltage, high voltage bus. You call it HV bus. Yesterday also we have seen um, HV bus how it is getting interconnected and connected and how it is getting disconnected. Also we have seen. And we have seen yesterday also how the cells are being arranged parallelly and seriously for a by-wire system. Okay. So here now we are going to see exclusively onto the pattern. So you also have the HV disconnection. The main purpose of this is to disconnect is the disconnection of the battery system from the vehicle HV circuit, and it also provides a galvanic separation for the battery and to the vehicle in the case of deactivation. Or it also helps you during the vehicle accident or something safety critical malfunction as well. And this HV disconnection it consists of it is having contactors. You have plus contactors and minus terminal contactors. And for activation of this complete system, you need to have a specific pre-charge circuit for both the terminals. When I was telling you have two terminals for HV disconnection. One is positive terminal and the negative terminal. You need to have a, a specific pre-charge circuit for both the terminal. It also needs to be included uh, into the vehicle HV circuit as well. In case of any overcurrent or an emergency, or in case of any setup, because of the terminals, we have positive terminal and negative contactors in the HV circuit. Then it will help you to limit the number of switching cycle and it will help you to overcome the lot of load during the operations. You also have detailed thing is not there, but okay. You also have the HV fuse and you also have eye sensors which is not mentioned here. See what is the function of the HV fuse? In case of overcurrent, what happens? HV fuse will disconnect the SRS voltage fuse will also disconnect the battery system from the vehicle HV circuit. Since you have the overflow or overcurrent, it will also cause the HV fuse to heat to get heated up, and as a result of high heat, what happens? You also get high thermal load. Okay, and this HV fuse will help you to decouple the thermal load, and it will also help you to prevent the thermal breakdown. Okay. Uh, the disadvantage of HV fuse that what you have as a part of the HV circuit, and we also have the sensors. It's not been mentioned here, but is also a part of HV circuit. And here you have the sensor which provides the current measurements for the complete vehicle HV circuit, and it will also sense current range during the charging and also discharging the battery. And the correct current and the level of current is also be measured with considering the operating range of the battery system. And we can also ensure the accuracy is being met with the help of the sensor because it gives the values during the operations. You have the electrical disconnection. electrical interconnection between the system called BMU, HV, and also the battery pack. And when I say electrical interconnection, it involves the low voltage to a high voltage connection between the battery cell pack and also all the related electrical electronics components. So the very important thing is you have the battery cell pack, okay, where the cells are being arranged either in serial or in parallel, and it is been connected between the battery cell modules and the battery cell interconnection system, interface system. Okay, you can call it as interface or interconnection components. Okay, when I say battery cell interconnection, it includes all electrical, mechanical, and the thermal connection between the battery modules, between the battery pack, and to the battery system. My cursor is. You also have the housing, and also you also have some of the external interfaces for your vehicle. You can see the communication between the interfaces or the architecture or the features between battery management system BMU and the battery pack. How the flow should be two-way flow or communication, and actually disconnection to the top for the battery pack. And the battery pack, you all the cells are arranged in series or parallel according to how there is an interconnection is happening. And also you also have the low voltage and also you have the high voltage, and how the communication or the signal is being moving, and that is also very much important. Okay, so as I was mentioning, you have the housing. What is the purpose of the housing? The housing must provide the vent gas outlets and also some of the vent gas in case of the overpressure into the battery system. And again, this will help you during the maintenance and also the repair of the battery system during the service point of view. And you also have the mounting interface connects the battery with the vehicle bodyworks also. As I was telling, you have different type of hazards like mechanical hazard, safety issues, electrical issues, thermal issues, chemical issues, and function safety issues. So all this needs to be considered as a part of the battery management system, and you need to have accordingly. Um, See, when I was telling you about the cell structure, let me explain about this. Um, okay, so as I was telling you, you have different safety measures related to function, related to chemical, related to mechanical, electrical, and and also chemical. Okay, all these safety aspects needs to be considered, and for this lithium-ion battery, you need to see. And as I was telling, the battery cells are being arranged either in series or in parallel into the battery management system architecture. So here they have taken battery cell, battery module, battery pack, battery system as L1, L2, and L3. It's just a categorization. And L0 is for a vehicle, it's a complete vehicle, and L1 is for the system, and L2 is for a battery pack, and L3 is for a battery module, and L4 is for a battery cell, which means you have a vehicle level, system level, uh, product, and when you say product, again it is again divided to many parts: battery pack and battery module and battery cell. Okay, and start with a cell, you start with the battery module, then you go with the battery pack and go with the battery system. The battery module normally it covers the various safety measures for a different interface of the cell to build up. And one argument which is coming for the packaging of the cells into the battery module, it is related to all the safety of mechanical aspects, the thermal aspects, or the chemical aspects. So when I say when I combine the safety features of mechanical and the electrical, or mechanical and the thermal, you need to ensure that the material that is being used for a battery management system can absorb the thermal energy in the battery module. Basically, you need to look for increasing the thermal capacity. When I say mechanical along with chemical, here you have the vent gas management. Okay. So here you need to ensure that each battery module provides a defined venting opening in case of any cell defect. So let us go to the different levels. Level one is battery system. So we'll start with level zero for a vehicle. So what happens when you consider the vehicle level? What is the prerequisite for you to look for the battery management system? That must be clearly defined, and you need to ensure that the battery system suppliers or the developers have to make some assumptions about the context in the sense what about the situation in which the battery will be used, and those assumptions have to be documented, and this also needs to be considered during the development stage, and the appropriate safety measures also needs to be taken at the vehicle level in order to prevent the malfunctions of the battery. And you have the next aspect called L1 level called battery system. Here, the battery system consists of battery pack, the housing, BMU, and other some relevant electrical electronics components which you have seen in the last slide of the architecture. Here, the BMU or battery management unit, what it normally coordinates all the parts of the battery, and it provides an interface between the vehicle and to the electrical electronics components. Here, this battery system is responsible for the detection and also for mitigation of error, considering the external system as well. And with respect to the functional safety, if I call, um, you have the BMU, which is responsible for electrical electronic system, as I said. It also helps for you to monitor the cell breakdown. Okay, you have the cells. This will also help you to monitor the cell breakdown, the future function safety aspects, and with respect to the BMU, and accordingly, and this can be the triggering condition, and this will help you to disconnect the battery, and if there is any thermal issue, then it will also help you to increase the cooling, and this will also help you to go for a good communication during the fault, or the initial stage of the fault for a battery system. Okay, so here the malfunction. See, there will be a lot of functions related to the battery management system. You need to analyze all the functions, but only one function is being taken care here. What is that function? Is related to overcharge. So you may have different other functions also, which can result in malfunction. Similarly, you have to look for that particular function, and you have to look for a safety aspect related to the chemical, thermal, electrical, mechanical function safety, organizational safety, and also the level of the vehicle status system. Like this, we need to have for other malfunctions as well. So here, for an example point of view, only the overcharge has been taken. And what are the safety measures that you need to take? So you need to take the safety measures related to the vent gas, as I was telling, the housing is related to the mechanical aspects and also the chemical aspect. You need to take care of it, and even the organizational level. And you have the cell voltage monitoring, which is a part of the electrical safety discipline and also functional safety discipline. And you have the charge interruption device CID, you call this related to the mechanical safety discipline. You have the monitoring of cell balancing, which is a part of thermal, electrical, and functional safety. So this is how you need to categorize. Okay, same thing you need to do it for the other functions as well. So when you consider like this, and this can be the input for you to do the system design. The concept design, and that is nothing but the item definition. And you can put all these requirements as a part of your safety goal as well. And this will help you to achieve not only the functional safety but also the complete overall quality management for your product. Okay, when I said thermal management, it is related to the thermal safety discipline and the mechanical and also performance safety. You also have a lot of cells which have been arranged either parallel or in series, and here you have the safety discipline related to chemical, thermal, electrical, mechanical, etc. And the last important thing is the warning of the persons and also corrective reaction to the persons related to the battery management system in case of overcharging issue, related to functional safety and also the organizational safety. Like this, the mapping needs to be done to ensure that the safety measures and also the safety disciplines have been met for a battery management system. This is at the battery level. Oh, okay. Sorry, something I think. Just a second. There is some swap. Yeah, yeah. Yeah, I was thinking. Yeah, I have swapped some of the. Okay, let me explain about the failure mode effect analysis. As I was telling, this FMEA, FMEDA, FTA, all this needs to be the part for you to consider the definition and also for you to come up with the safety goal. Okay. Um, so here you need to consider the FMEA. It needs to be applied on during the development and also um, you need to consider with respect to the complete vehicle point of view. So in vehicle we have chassis, we have the powertrain, we have the braking system, and this battery is coming in a part of a powertrain, and and even in powertrain you have a transmission, you have a powertrain controller, you have battery, you have the engine, and again when you said HV battery, when we have seen a battery management unit, you have BMU and also battery pack which is having the cells that are being arranged seriously or parallel. So here you need to do the FMEA failure mode effect analysis, and this FMEA will help you to ensure that to understand what can go wrong or what can be the propagation for the failure and what can be the traceability for the failure. That can be the input for you to for a safety goal and also when you go for a item definition. So those things needs to be taken care. You need to understand what is the failure cause, what is the failure mode, and what will be the effect of the failure. So if there is any failure because of the battery, what can be a failure mode, what can be the failure effect? You need to consider that with respect to your component level, system level, and also the complete vehicle level. Once you start with the component and go with the system, then you go with the uh, complete vehicle. So here it is very much important to ensure that the safety has been meant for driver, passengers, and also it's not only for your vehicle, even for other traffic participants also. Okay. So that's why you need to very apply this FMEA concept. And once you apply the FMEA, this will also help you to go for a categorization. So this we have seen it, right? And again, see what is in your hand is the controllability is in your hand. See the severity or the probability is not in your hand. Okay, the probability of the accident is not in your hand, or the severity is also not in your hand. Okay, but what is in your hand is the controllability. Based on the controllability, if you have high control over the fault or a system, then you can easily achieve the quality management. And if the probability is on the higher side, then again, if the severity is higher and probability is higher, then you may go with the still D category, which is on the higher side, high level of. You need to give more concentration when you have the D level. Um, but in the case of the battery maintenance, what you have taken here, what can be the hazardous event or risk? What is there? So here you can have the fire, okay, because of the internal cell defect during something like parking situation when the system is getting deactivated. So that can be the one of the failure modes. And what can be the risk for a person around the vehicle? If during the parking condition, no one will be there, so there will not be any risk during the parking if in case there is any internal defect uh, during the parking system. Okay, and sometimes what happens, the harm, what can be the possible harm? Because of the burning of the cell, it causes smoke, right? Even though there is no harm to the people because it is in parking, no one is there inside the vehicle. But because of the burning of the cell, what happens is the smoke is coming out, okay, because of the burning. And when you when the people on the nearby, when they inhale the smoke coming out of the burning of the cell, again this may also cause some of the health hazards to them. And even sometimes what happens, person here, because of the smoke, it can also burns, they can also get some of the burning light injury, it can also happen. And if what happens again, even though there may not be any life threatening uh, because of the burning, but still there can be some health hazards, or sometimes even the light injury can happen later to the burning marks if the people nearby are present. So accordingly, you need to go for a the acid categorization. Okay, just an example I have given you. Detailed explanation is not there, but just an overview I have given. So accordingly, you need to determine the acid category. When you're going for a function safety concept, okay, called a concept, as I was telling, you need to look for the external measures like the considerations, and also the other technologies that have been available. So here, as I was mentioning, you have the sensors, you have the controllers, and see, when I say electrical electronics, you need to have the consideration with respect to all the parameters and also all the features or all the requirements. That's why when you go for the malfunctions, it's not only to one aspect you need to look for the malfunction, but even you can also have the sensors as one of the malfunction and what can go wrong safety point of view. Okay, and even when you take the actuators or controllers, okay, you also have a lot of controllers. Um, Again, accordingly, even the topology, yesterday I was talking, we have different type of topology, and star topology, bus topology, and hybrid topology. So accordingly, you can also have the system for your particular requirements. Okay. Um, so what is the overall objective what we have covered so far? The overall objective here is that we need to ensure that the safety goal is being met during uh, the malfunctions, and accordingly we are going to have even we also understood that FMEA is required. um, FMEA, FMEDA, FTA,